Hey there! Today we are going to solve another LeetCode problem named container with most water. Medium level, and it goes like this. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height of I. Find two lines that together with x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. There is an example here. You can see the lines, you can see the container of most water. The water inside is represented with this blue rectangle, and obviously the amount of water in the container is represented by the square of this rectangle. There are some constraints here. The most important one is that the number of lines is greater or equal to 2, which means that we shouldn't care about edge cases like 0 lines or one single line in the array. All right, so let's start to work on our issue by introducing a variable max square, the square of our water rectangle, which we would initialize with 0 and try to maximize in this method and return as a result. We would need two indexes of our sides, so the left side index and the right side index. And the good starting point for our search is to check for the container of the biggest width. So it's going to take all the space from the most left side in the array to the most right side. So initially the left index is going to be equal to 0 and the right side is going to be equal to the last index of our array. And whenever we would look for the maximum square, we could calculate the square of our water rectangle represented by these sides by multiplying the width of the container by the water level inside this container. So the width of the container could be found as the right side index minus left side index, and the water level in the container is equal to the lowest side of the container. So we would compare two heights over here to pick the minimum from left side and from right side. And if this square would be greater than our max square, then we would be able to replace the max square with the new value. All right, so where can we move from here? So we could either replace the left side of the container or the right side of the container. Let's check what would happen if we would replace the side of the greater height. In this case, we could potentially find the side of the greater height or the same height, but the water level in such container would stay the same. And because we are shrinking the container, the amount of water would also shrink. And it would be even worse if we would find the side of the lower height. In this case, we would also encounter the water level drop, which would make the things worse. All right. And what would happen if we would replace the side of the lower height? We still could have a bad case because we could find the side of the lower height, which would cause the water level drop, or the same height. In this case, well, the amount of water is still shrinking because we are shrinking the width of the container. However, we could find the line of the greater height, so great actually that the increase of the water level would completely overlap the shrinking of the container, and we would find the container which could contain more water. All right, so let's compare the sides of our container. So if left side is less than the right side, then we could replace the left side and pick the one closer to the center. Otherwise, we are going to replace the right side and pick the one also one step closer to the center. So this is the code which calculates the square for one couple of left side and right side index. We have our starting point, so we could put this code into some kind of loop, and we should provide some condition when should we continue this calculation. So obviously at some point we are going to slap both sides together, and after that any calculations are meaningless. So let's check that the right side index is greater than left side index at any point of time. And that's it. Let's check for any compilation issues. Nothing over here. And let's submit the solution. Nice. So as you can see, the execution time of this solution on all of the test cases is technically 0 milliseconds. Basically, it stays somewhere on the edge of the threshold, and that's why it beats 100% of other submissions. And that's it for today. If you'd like to see me solving other LeetCode problems, then put your request to the comment sections. See you next time. Cheers.